All right, here are solutions for quiz 8 for Math 251. This first problem is a related rates problem, and you were told the relationship between the variables, or I guess functions in this case. You were told surface area, which I'm just going to use S to represent, is equal to pi times the radius of this right circular cone, I guess the base of the right circular cone, times that same radius plus the square root of the height of the cone squared plus that radius of the cone, or the base, squared. What I'm getting at is that you're given this formula right here. And what you're eventually going to do is take the derivative of both sides of this equation to solve for stuff. How do I know that? Well, if you go through and read the problem, it says the surface area is increasing at a rate of 2 centimeters squared per second. So I'm talking about the change in surface area, so not S, but S prime. And since it's increasing at a rate of 2, I'll say S prime is 2. And the radius is decreasing, so again, I'm talking about the rate of change of the radius in this case. And since it's decreasing at a rate of 1, I'll call it negative 1. And h prime is what the question is asking me for. It's asking about the rate of change of the height. So where am I going to get an h prime? I'm going to take the derivative of both sides of this equation. That's how I know it's a related rates problem. More information was given to me. I was told that the surface area is equal to 24 centimeters squared, 24 pi centimeters squared, and the radius is equal to 3. You might notice that h was not given to you. That's okay, you can solve for h. Actually, you have a couple of options. Option 1 is to solve this equation for h and take the derivative of both sides of that equation. So maybe I write that over here. Option 1, solve for h. So the way I do that is I would divide both sides by pi times r to get this over on this side, and then I would subtract r from both sides of the equation. And I would have s over pi r minus r is equal to the square root of h squared plus r squared. And now if I square both sides of the equation, I get s over pi r minus r squared equals h squared plus r squared. I'm trying to solve for h, so I would subtract r squared from both sides of the equation. S over pi r minus r squared minus r squared equals h squared. But I don't want h squared, I want h, so I'll take the square root of both sides of the equation to get here. You could solve for h, then take deriv of this, and I'll put dot dot dot. The advantage of doing it this way is you won't have any h's in your answer. You'll have h prime equals this mess over here. You'll never need to know what h is equal to. That's option 1. I imagine most people do option 2. Which is, I don't know, maybe first find h. So over here I want to solve for what h is equal to, which sounds a lot like solve for h here. I don't know. Anyways, I know that s is 24 pi, and that's equal to pi times the radius plus the square root of h, which I don't know, squared, plus the radius squared. I have this relationship. You stare at this thing, you'll see there's only one variable here, h, so I can solve for it. Divide both sides by 3 pi, you get 8 is equal to 3 plus the square root of h squared plus, maybe I'll write 9 because that's what 3 squared is equal to. Subtract 3 from both sides of the equation, you get 5 is equal to the square root of h squared plus 9. Square both sides of the equation, you get 25 equals h squared plus 9. So h squared equals 16. So h is equal to plus or minus 4. But since I'm talking about the height of a cone, I want the positive solution. H is 4. All that work just so I could write a 4 right there. But now that you have this 4 right here, I don't need to solve this equation for h. I can just take the derivative of the original equation. Then take deriv of original equation. So that's the method that I'm going to actually do. I'm going to show the full solutions. This one I kind of said dot dot dot, like you can finish it on your own if you want. I'm taking the derivative of this thing. Derivative of the left-hand side is s prime. On the right-hand side, I would have a product rule. Playing the role of f is pi times r. So f prime would be pi r prime. G would be r plus the square root of h squared plus r squared. Maybe I'll even denote that. This is kind of f prime, and this is g plus g prime, which will be a little bit of a mess. The derivative of r is r prime, plus the derivative of stuff raised up to the 1/2 power is 1/2 times the stuff to the negative 1/2 power. The stuff in this case being h squared plus r squared. But then I'm not done. I have to multiply that by the derivative of the inside stuff, h squared plus r squared, which is 2h prime plus 2r prime. This is all g prime. And I want this entire thing to get multiplied by f, which is pi times r. F prime g plus g prime f. Okay, a little bit overwhelming, but at this point I could start plugging in numbers if I feel like it. I got s prime is 2. So you could either solve this for h prime if you wanted, or you can plug in numbers if this looks a little bit intimidating to solve for this h prime that's over here. I got 2 equals pi times r prime, but r prime is -1, so it's 2 equals negative pi times r, which is 3, plus the square root of h squared plus r squared. Well, h squared is 16, and r squared is 9, and 16 and 9 gives me 25, and the square root of 25 is just 5. So I get 3 plus, how about the square root of 25? I'll write it all out. The square root of 16 plus 9 plus r prime, which is -1, plus 1/2 times h squared plus r squared to the negative 1/2 power. That's the same as 1 over the square root of h squared plus r squared, which as we saw before is 16 plus 9, times 2 times h prime, so 8h prime, plus 2 times r prime, which is 2 times 3 times -1, aka -6, times pi times r, which would be 3 pi. So I have this mess here. I want to solve it for h prime, guy there. It might help to rewrite this thing without the square roots in there, so I'll write 2 is equal to, let's try to clean this up as best I can. This is 25, the square root of 25 is 5, 3 plus 5 is 8, so I have -8 pi coming out of this whole thing, plus -1 plus, and then this is 1/2 times 1/5, because the square root of 25 is 5, so that's equal to 1/10 times 8h prime minus 6 times 3 pi. Alright, I want to get this h prime by itself, so maybe I add 8 pi to both sides of the equation, 2 plus 8 pi, and then I could, let's be careful with my parentheses here, this 3 pi needs to get multiplied by all that stuff. That's better. So now I can divide by 3 pi. And I would get that equals -1 plus all this stuff. I kind of like to write that as 8h prime minus 6 divided by 10 minus 1. Here's the -1 here, and 8h prime minus 6 divided by 10 is right here. So then you could add 1 to both sides of the equation. But really 1 is 3 pi. So I guess I would get that I have 2 plus 11 pi over 3 pi. Did I say 1 is 3 pi? That's a stupid thing to say. I'm adding 1 to both sides of the equation, but really I'll think about that 1 as 3 pi over 3 pi, so that when I add that, I get an extra 3 pi in the numerator, which gives me this 11 pi. Anyways, that's equal to 8h prime minus 6 over 10. So if I multiply both sides by 10, I get 20 plus 110 pi over 3 pi equals 8. Why is this not working? H prime minus 6. So add 6 and divide by 8, and you would end up with, okay, let's add 6, which is really 18 pi over 3 pi. I'd get 38. No, I wouldn't. I'd get 20 plus And then if I'm adding 18 pi over 3 pi, I get 128 pi over 3 pi is equal to 8h prime. And so finally, if I divide both sides by 8, I get h prime equals 20 plus 128 pi divided by 24 pi, that 24 coming from this 3 times this 8, which I guess I could reduce. Do these guys all have a 4 in them? I think they do. Do they all have an 8 in them? Nope. So I could factor out a 4 from the top and get 5 plus. If I factored out a 4 from this, I'd get 32 pi. And if I factored out a 4 from the bottom, I'd get 6 pi. I'm going to say h prime equals this, or some equivalent expression. What a mess. That was a hard problem. Anyways, that's your h prime. Maybe it would have been easier to do it this way. Who knows? All right, find the critical values. I think that's a little bit more straightforward. To find the critical values, you have to find the first derivative. So f prime of x. To find the first derivative of this function, I recognize that it's a sum of two parts. So I take the derivative of the first part and get a 1 here. Take the derivative of the second part and get 2/3 times x minus 1 to the negative 1/3. So this is my derivative. And then I guess times the derivative of the inside stuff here, which is just a 1. And so for critical values, I get critical values when one of two things happen. When f prime of x is undefined. So that'll happen if I divide by 0. I'll divide by 0 if, so how about this? Let's rewrite this. This is 1 plus 2 divided by the cubed root of 3 times, I need a little more room, 3 times the cubed root of x minus 1. So if you write it like this, it's a little bit easier. F prime of x is undefined if 3 times the cubed root of x minus 1 equals 0. Because if this thing equals 0, I'm dividing by 0. That's bad. It gives me something that's undefined. Well, I could divide both sides by 3, and then I could cube both sides, and I could get that this happens when x minus 1 equals 0, aka when x equals 1. That's my first critical value. It also happens, this critical value is when f prime of x is undefined, which happens if, maybe I'll just put a period there, good enough. And also if f prime of x equals 0, this is not translating very nicely. Well, to figure out when f prime of x equals 0, I'll take one of these expressions, it doesn't matter which one you use, and set it equal to 0. So I have 0 equals 1 plus 2 divided by 3 times the cubed root of x minus 1. So if you subtract 1 from both sides of the equation, you get negative 1 equals 2 over 3 times the cubed root of x minus 1. So I can multiply this stuff up top and get negative 3 times the cubed root of x minus 1 equals 2. So now if I divide both sides by negative 3, I get the cubed root of x minus 1 equals negative 2/3. So I cube both sides of the equation. I get x minus 1 equals negative 8/27. So x is equal to, if I add 1 to both sides of this equation, 1 is 27/27. So 27/27 minus 8/27 gives you 19/27, which is my other critical value. Whew, and mercifully this quiz is over, so I'll stop this video here.